Hi everyone, my name's Joe Clark. I work for Atlassian, and this talk is The Life of a Feature, Best Practices for Shipping Quality Features in a Timely Manner. So this talk is about strategies you can use to add to your feature development lifecycle to improve quality and reduce shipping times. And I flippantly said this morning that this is not about testing, and that is true. This talk is not about testing, but I'm not saying that both manual and automatic testing aren't important. This is a higher level discussion around, regardless of whatever your feature quality practices are, there's actually a whole nother level above your kind of day-to-day development processes that can actually influence whether or not you're building high quality features. The content of this talk is based on my experience working at Atlassian and the things that we do to try and achieve this. I've been with the company for about 5 years now, so in internet time, that's almost an eternity. Most of my career, I began in the Sydney office, which explains my colonial accent. But now I work in San Francisco as a product manager in our support team. This is my first time in Germany, and I'm really excited to be here. But also, I was a little bit sad to leave my adopted home, the beautiful San Francisco, with so many famous landmarks like the Golden Gate Bridge and Alcatraz, and you can see Sutro Tower in the background. But for me, the most exciting landmark in San Francisco, and the thing I was most excited to see when I first moved there, was the Lucasfilm Studios. San Francisco is the birthplace of Star Wars. George Lucas began here. The forest moon of Endor is Muir Woods, just across the other side of the bridge. I'm a big Star Wars fan, and I was so excited to be there. And actually, I felt I had a bit of an emotional rush standing in front of that photo, in front of that statue when my wife took that photo. So I apologize in advance. There's going to be a few Star Wars references scattered throughout this presentation, but I promise nothing from episodes 1, 2, or 3. Only the good movies. So we're really here to talk about this question: how do you build a feature? And when I started as a young developer, I thought that answer is easy. You get a spec, you write some code, some unit tests if you have some extra time on your hands. You probably make sure you haven't broken anything in IE, because sometimes that happens. And then you get a code review and you commit it and you're done. That's how you build a feature. In my elderly wisdom now that I'm a product manager as well, I realized the answer is more complicated. There's more involved. And actually, I can think of someone who would probably agree with me on this. This guy, he wanted to build a feature for his Navy, his Imperial Starfleet. He wanted to build the biggest laser in the galaxy, so big that it could destroy an entire planet. So he got his engineers to start building it. There was a tight schedule. They knew the rebel base was about to be found, so that laser had to be ready as soon as possible. So they went straight into building it. The engineers started working on it. They had some questions. Lord Vader, how are we going to move this laser around? And he said, not going to do the voice. He said, well, just put it on a space station, okay? Not a big deal. And they said, okay, what if it gets attacked? How will we defend it? He said, well, put some more little lasers on the space station so we can shoot at anything that's coming at it. And they said, okay, cool. What about the thermal exhaust that comes from the engine inside the Death Star? He said, don't bother me with these unimportant details. Just put a small exhaust port on the side of the space station so they can get out, and let's get this laser operational. And it didn't go so well. I guess in software development terms, this was a failed feature, a low quality feature. But what went wrong? This was the most dominant military power in the galaxy, and they failed at something so basic. Really, I believe it's a failure to understand the full development lifecycle, how a feature goes from inception through to delivery. All Darth Vader thought about was the development phase. He just wanted to build it. And the reason for this, I think, is that development is really the simplest part of the lifecycle. And by simplest, I don't mean it's easy. I mean it's the most tangible. It's the most easily understood thing that you can explain to a layman, a layperson, about how feature development happens. So we naturally gravitate towards it, and we often forget that it's only a small part of a larger process. Before the development phase, there's actually a discovery phase that happens first, where you even try to validate and discover what you should even build in the first place before anything gets produced. After development, there's delivery. You've got to think about, after you ship your feature, what happens to when your customers start using your feature? And is it still going to be a high-quality feature beyond that point. So in this presentation, I'm going to touch on a few points at each phase of this life cycle, some things that you can try in your own workplace to ensure that your features are high quality and shipped on time. So there's a lot to cover. My 4-year university degree tried to cover this entire gamut of conversation. So really, we're just going to blaze through at light speed and just touch on 1 or 2 things at each phase. Whoop. So the discovery phase, a critical moment in the development of a feature. The features that you build are not going to be high quality features if you don't start with the beginning building something that you know is actually worth building. Building a high quality feature doesn't just mean it has no bugs. High quality feature means A, no bugs, but B, the feature actually has to solve a real need for your users. And C, it even actually has to do a good job doing it. So where do good features come from? If it's so important to know that you're building the right thing, how do you get started with that? And I'm sure we can all appreciate that most features in software development begin with an idea or a spark. Someone is in the shower and they come up with something, or someone has a conversation with another person and it ignites the possibility of something new. If you start with a great idea, then you can refine it and cultivate it, turn it into a great use case or a great user story, and then from there, it eventually becomes a great feature. So one place that ideas can be sourced from is your own customers. And at Atlassian, we're very lucky that we have an extremely large customer base. In fact, Sarah, who's here from Atlassian, just told me can I tell this, how many customers we have? Is that? Yeah. We just hit 50,000 customers. 40,000. Oh, yeah. Oh, okay. Well, ask me again in a year. 40,000 is still a big number. So you have 40,000 customers, each you have, between 10 and 10,000 users, and they all have ideas. So that's millions of ideas in this untapped resource. So there's so many ideas here, though. A, you need to capture them, but then B, of all these ideas, how can I tell which ones are the good ones? We need some help weighing them up against each other to validate how we're going to spend our scarce resources to turn these ideas into features. So at Atlassian, we're really strong proponents of public issue tracking as a way of, amongst other things, validating ideas for feature development. Public issue tracking is obviously really common in the open source world. It's hard for an open source project to gain any traction if you're trying to hide away exactly what you're doing and what your bugs are. But when Atlassian first started doing this in the early 2000s, it was really quite novel for an enterprise business-to-business software company to actually be totally open about everything that was being done and all the bugs that existed. So we use our own issue tracking software, obviously Jira, for both customer feedback and controlling our developer schedule. And you can see both of these in action on jira.atlassian.com. So public issue tracking means it's not just a suggestion box on your website that maybe an intern or your CEO's younger brother checks on his school vacation. It means that you open up the workings of your development team to the wider internet. Customers can report bugs, give suggestions and feedback. They can comment on in-progress work, and they can do that on equal footing with an employee. They have the same permissions and the same right to contribute as anyone who actually works for the company. Not even this, but developers can respond in kind. So any developer who look at any issue, see a customer has commented on it, and reply back and have a conversation about that issue. There's no bottleneck, there's no controlled messaging or someone sitting there blocking anything from happening to make sure that we're saying the right thing or that it's on message. Right? It's totally free and democratic. This is crucial because ideas can actually come out of that conversation. So by having that freedom to discuss freely, ideas can spontaneously appear in a system that you control and can mine for data. So this has a number of very real benefits. The first one is that you're hearing directly from customers about what they want. They're actually giving you tangible suggestions. Hey, I'm customer B, I have this product, and it would really make my life better if you did this thing. So that's great, very useful. Sometimes what a customer proposes isn't exactly what you should do. I think Henry Ford is the famous example of someone, hearing a customer's pain, but then deciding that actually I've got a better idea. But it still gives you kind of that nugget of truth that you can then expand upon. Secondly, by developers and users communicating with each other, it forms empathy and bonds between those two groups of people. I'm sure you can appreciate, you can probably think of someone in your own employment history. There is a developer who really has no empathy for the users that they're building for. And that's a real problem because you're not going to get that high quality because it needs to solve a real need and it needs to do a good job of it. If you have a developer who doesn't care about the user that they're building the feature for, you're instantly a step further away from achieving that goal. And the thing I said earlier about needing to know how to weigh up the different issues and ideas to see which ones are the best, public issue tracking normally has some kind of voting feature or commenting feature where people can kind of put their money where their mouth is and kind of throw their support behind different ideas. So if you have this issue tracking system that's wide open and everyone can see everything that's been suggested, it's really easy for people to find and latch on to the ideas that they think are the most important, and they can vote or add their +1. And then from these tens of thousands of ideas and tens of thousands of customers, now we have some actual hard information we can use to rank them against each other. And that doesn't necessarily have to be the gospel, but you can still use that to feed into your own decision-making process. Public issue tracking is not easy. It can be a very dangerous undertaking to go upon. It takes a real investment in time and energy to listen to your customers, try and aggregate all that feedback, and then channel it somewhere useful. The worst thing you can do is give the impression that you're being open. So you just set it up, and then you walk away. And your customers are trying to talk to you, but you're not listening. And it's going to make them very frustrated. It's a lot like being stuck in a trash compactor full of garbage. You really have to dig around and spend what feels like wasted effort before you uncover something at the bottom that's really useful. So back to ideas. We know we can talk to customers. Another place we can go, your own engineering team. So these people, men and women, spend a lot of time working on your product. So it's only natural they're going to kind of, because their brain is focused in that area, they're going to come up with ideas and suggestions for the stuff that they're working on because that's just where their brain space is. The problem is that these ideas and these sparks in their mind may never mature into a full feature if they're not given room to be nurtured and to be grown. That's a big problem because spending money on development is really expensive. Atlassian was recently valued as a $3 billion company or something, which still blows my mind. But that entire valuation and the revenue that we make, we spend over a third of it on research and development, which is mostly the cost of actually having full-time staff in that department. So if these people that you're paying a lot of money to get their best effort from, and they have these good ideas that can't come to fruition, that's a huge waste of money and potential. So the most important thing that we do to solve this problem is allowing for structured creative time to happen in the workplace. It needs to be culturally accepted to slow down and think about things in detail and be able to work without actually having anything to show for it at the end. And that sounds obvious in some way because you often think about the creative process being hard to quantify. But in a very engineering-focused culture like Atlassian, it can be really difficult to try to convince people that you can have an engineer spend a week's worth of time on something and at the end maybe not have a lot to show for it. Maybe all they did was take their idea and maybe just it's a bit firmer now and a bit closer to being a reality. Or they have some mock-ups or some feasibility studies into whether or not it could actually work. Or it could be a total failure. That idea might not be possible for a variety of reasons that didn't get discovered until more time was spent on it. And failure is an important part of success in creation. We also found the best results happen when the creative time is regular and scheduled. If you just kind of have arbitrary ad hoc downtime where people can do whatever they want and slack off, the results aren't as good. So at Atlassian, we have several avenues available for developers and other staff to do this. One which is really popular and well known is 20% time, which is famous from Google and other tech companies like that. And it allows engineers to spend up to 1/5 of their time, working on things that interest them and motivate them, as long as it's kind of roughly work-related. That's really good. 20% time, up to 1/5 of the developer's time, is a huge investment in time. So it gives plenty of time for an engineer who has a good idea to kind of work it through to its logical conclusion, whether that be a decision not to move ahead or yes, let's actually turn this into a real feature. The downside is that because it's kind of individual focused, it's 20% of your time and you do what you want with it, it can be really hard for an individual engineer to kind of achieve anything because they want to spend their 28% time being creative, but if they want to actually get something done, they've got to be their own developer, their own project manager, their own designer, their own tester, before they get to a point where the rest of the company will say, yes, let's go, let's do that. So what ends up happening is that ideas often start strong, but then peter out when kind of the other heavy lifting work starts happening. You end up with not 20% time, but 2% time. So as an alternative, we also have a thing called Ship It, which is a company-wide 24-hour hackathon that has a competitive element to it. So everyone gets 24 hours to try and produce something, and then at the end, we have some voting and some drinks. It's very relaxed and fun. And we declare a winner. Use the best Ship It project. You get a trophy and a cool t-shirt. In case you haven't noticed that Atlassian is kind of just a t-shirt company that makes software on the side. So to contrast this, the benefit of Ship It is that teamwork is really strongly encouraged. So if you're that individual developer who has that great idea, but you don't have kind of the wherewithal to do all that work that's involved, you can pair yourself with the right people to make success happen. The downside to Ship It is that time limit, which is important for the competitiveness. If you only have 24 hours to do something, you're generally going to cut corners, you might hard code things to make the presentation look good, you're probably not going to think too much about edge cases and just do the happy path. So you end up with a half-finished thing. And then once the excitement and intensity of Ship It is gone, it's really hard to see a way through to completion for that feature. So what we've started doing organically, this is not something that's top-down, this is just individual teams have started doing this and it's gained momentum, is called an innovation sprint. And that's where kind of when you naturally have some downtime in your team, so you just shipped a big release and you want to give everyone like a bit of a break, even though traditional Agile says constant velocity is the goal, the real world says that you can't push people to 100% all the time. So you're, after a big release or a big milestone, we schedule in a sprint where there's no committed velocity. It's like, okay guys, now's the time, all the stuff that bothered you in the retrospective that you really want to fix, spend 2 weeks doing it, and let's see how far we get, and maybe even we'll actually ship something. So this is way more structured than 20% time, and for the right kind of person, that's really helpful, but it's less effort for the entire company to organize an entire 24-hour hackathon. So it's a nice middle ground, and it's been really successful. So you might say, well, why have all these 3 different things who have the same purpose? Why do you need 20% time and Ship It and innovation sprints? And the reason is because they each produce different kinds of valuable results. And most importantly, they're good at motivating different kinds of people. Some engineers really enjoy the competitive, high-intensity aspect of Ship It, and they'll work 24 hours nonstop with no sleep to vindicate their idea. Other engineers are more laid back, and they really love kind of the slow burn of 20% time, where they just kind of get time to ruminate and think and really knuckle down over a long period of time and achieve something. 20% time is not just an advertising perk to hire people. It's actually a key part of our strategy to ensuring that our products stay innovative and competitive, and also it makes everyone on the team feel like a hero. So we're at the development phase now, and the engineers are thinking, great, finally I don't have to talk to anyone, put my headphones on and write some code. Unfortunately, in 2014, development's not really about that anymore. There are still going to be individual geniuses who achieve amazing things, but in general, software is becoming more complex and more widespread, and bigger projects are being tackled by bigger teams. So you can't rely on a hand solo in your team to really achieve the great success that you need. At Atlassian, we believe that software development is really a collaborative endeavor. The hardest part of building software is not about your technology choice or your platform stack. It's about how you bring a big group of people together to achieve a big, audacious goal. And even if you have someone on your team who can bullseye womp rats back home in their T16, you can't rely on that because that's just the force. This is something we felt at Atlassian as our company has grown. When I started in 2009, it was about 200 people. Now we have over 1,000. So we've got 5 times as many people, but we've still got kind of the same amount of stuff that gets worked on. So you have more people working on the same amount of things. And I'm sure you know from kind of software engineering 101 that as you add more people to the same project, things slow down. You're all trying to access the same resources and conflicting, and there's bottlenecks happening. And the biggest bottleneck will be actually releasing your product. All these engineers need to synchronize and line up at the same point in time so that all the work is done, all the critical bugs are fixed, and you're not going to accidentally ship anything that's halfway through being completed. Once this happens, your features are no longer getting released on time, there's going to be delays, and your customers are going to get frustrated. So at Atlassian, we solve this by breaking down our product teams into smaller groups with a mandate to be able to release independently. So instead of one giant team and one giant code base, we instead break down our teams into smaller groups of 5 to 10 independent people. And then their job is to break down that giant code base into smaller, isolated chunks of functionality. And then once this happens, each team is free to release on their own schedule. And when the time for the big product release comes, we rely heavily on automated integration tests and automated release processes to ensure that all those different artifacts can be pulled together into one final artifact for the customer to download, and that we're confident that that integration process is going to be successful because we've got test coverage. So I feel bad at making fun of Darth Vader just before, so here's a success story for Darth Vader. When he really wanted to capture Han Solo, he did this really well. He hired the galaxy's 5 most fearsome bounty hunters, and they all had the same mission, capture Han Solo, but they were able to act with full autonomy and full independence and seek out what they thought was the best way to do it, and in the end, that worked really well. So breaking down into independent teams can really have risks. Here's an example of something that goes wrong. Here's developer saying, this module is owned by the other team, so I can't touch that code without consulting them. And this leads to developers thinking like they don't have responsibility to change the entire system. They get locked into thinking about their own little part of the world. This leads to people saying, my team only works on this feature, so I don't need to bother learning about the other parts of the system. And it's a big product, I really just want to focus on this one little bit. And if you're working in these independent silos, you end up with kind of a stagnation of knowledge, and the way that the system works in different areas is not being passed across the whole team, and no one knows how the entire thing works together. Which leads to this inevitable conclusion, developer saying, we need more work on our backlog, our team's running out of stuff to do. So because we work on feature A, let's all brainstorm all the possible improvements we can make to this feature and this module. And now you're in a situation where people aren't thinking about improving the product. They've got very narrow-minded thinking about what they're even able to spend their time on. So instead of thinking holistically about improving the entire product, everyone's just focused on very small incremental improvements. Teams still need to be empowered to improve the entire product. If it doesn't, that high quality of the product over the whole about solving a user's real need is going to become less relevant over time. So at Atlassian, we solve this by turning our smaller teams into what we call theme teams. So instead of forming your teams around those small modules that you've broken down, instead we think about, okay, what are the goals of this product over the next 12 months? Where do we want to take Confluence, our wiki? Where's it going to be in a year's time? And the product managers and other people will get involved and say, okay, here are our top 3. This year, we want to make the experience for new users getting started really great. It's also really important for us to solve some of the performance and scalability problems we're having with our large enterprise customers. And then we've had a lot of people say that they really want to build great integrations with Confluence, but that the API is not good enough. There's things that the product can do which the API doesn't emulate well enough. So now, instead of 3 functional modules, we have 3 lofty goals that we know we want to push features and development in the direction of. So that's where you put your teams behind. It's not Team A and Module A. This is the new user growth team. This is the enterprise scalability team. And this is the integrations team. And that empowers everyone to feel like they have ownership of the entire product, but you still get that nice independent release process by having the product already broken down into smaller parts. So if you arrange your team to achieve your product's goals, your features are going to be more relevant to the purpose of the product, which gives you higher quality as a nice benefit. Focusing on your goals can make your teams more effective. Even if your goal is to hold off the Empire long enough for your medical transports to escape, it can still be considered a win, even though in the bigger picture, other people might say it wasn't. So you probably got questions about how you have all these independent teams working with all these independent artifacts, releasing whenever they want. Who is responsible for testing that mess and making sure it works? Well, it's called Quality Without QA, and if you want to hear about it, you should listen to my colleague Tim Pedersen's talk tomorrow on Thursday afternoon at 1:30, where he's going to talk more about that process and how Atlassian scales that QA to achieve that kind of massive problem that we have with our approach. So the delivery phase, the last leg. Boba Fett knows that delivery is all about getting your features to your customer as soon as possible. Jabba the Hutt wanted his Han Solo statue ASAP. So part of this process in software development is about releasing features as quickly as possible, continuous integration, that kind of thing. I really wanted to talk about that, but I haven't got a lot of time, so I'm going to skip over that. I'm going to talk about this question. Who fixes the bugs? Developer teams, whenever you talk to them about delivery, okay, you ship your feature, now what? They're like, okay, there's going to be bugs, who's going to fix them? And it's something we often forget about when we're doing these, if you have your teams kind of doing feature development focus. You probably wish you had a bug fix team that looks like this. Maybe Oracle does. Unlimited resources, can tackle every bug that gets reported. The goal is 0 defects. In reality, your bug fix team, if you have one, probably looks more like this. It's a small, experienced team of senior people, and they need to be surgical. They can't solve every bug. So they need to find the bugs that have the biggest pain, that require the least effort to fix. And that's really the bug fix team's job. They should be focused on long-term stability. And that's not going to happen if they're constantly fighting fires caused by stupid new regressions that happen every new release. They're going to be going backwards instead of going forwards. So we solved this at Atlassian by using something called feature warranties. This is something that's been started in the Confluence team, and I actually think it's going to be rolled out across more products too, because it's been really successful. So a feature warranty means that after you release a feature, if any bugs are found in that feature within 3 months of it being released, that bug is the responsibility of the feature team to fix, not the bug fix team. And that might sound a bit draconian or mean-spirited, but it's more about just kind of everyone realizing that bug fix is everyone's responsibility, not just the bug fix team. People weren't thinking about the delivery phase because there were no consequences for them if they released low-quality features. So this is the Confluence team's warranty bug backlog over the last year. As you can see, it took about 3 or 4 months before this feature warranty policy actually had any effect. And that's because it's easy to kind of write things down on paper and say, this is the way we're going to do things now. But it actually takes time and effort to really kind of get everyone up ready to go. They're like, okay, yep, this is just how we do things now. And it takes, a little while for people to embrace that change and get used to it being the new normal. And after we implemented this policy, you can see that it took about 3 or 4 months, and then we had a massive drop in kind of warranty bug quantity. It was up at around 100 open bugs. Now we're hovering down around 25. And the goal is actually 20. So part of this process was actually setting this as the bar, 20 bugs, and then once people have something to aim for, it gets more achievable. So in summary, I would say to you, innovate together. Improving your product and thinking of new ideas is everyone's responsibility. Better thinking in the early phases leads to better features, and if you do that in collaboration, then the ideas are going to be even stronger. Release independently. Smaller independent teams can release modules faster, and by aligning your teams with the goals of your product, you're going to build features that are better suited to meeting the needs of your users. You need to share responsibility. Quality is responsibility for everyone. It's not just the testers and the QA engineers that need to make sure that quality is high. There's so much going on and so much that's happening so fast in software development these days that your engineers need to be smart about quality as well. And finally, may the force be with you. Thank you. Did anyone have any questions in the 5 minutes remaining? Yeah.
How exactly does it look like to release it? And still you have products like Jira or Move, which you release as a whole, I guess.
So how do we achieve that when people are working on these small isolated components? So actually, that was part of my presentation that I took out because I was worried about taking too long. So actually, we use OSGI. So all of our downloaded products like Jira and Bamboo and Confluence, these Java web applications, we use a plugin framework based on OSGI so that all these teams can produce what are essentially plugins for all our products. And they build this artifact as a jar file, it adheres to a certain API, and then when we build our product to release it, we'll actually just we have a dependency file that says Bamboo has these plugins. It has the Git plugin, it has the CI plugin, it has the feature branch plugin. And when we build Bamboo, we're actually just grabbing all those artifacts out of Maven and shipping them as one unit. And then when the customer actually runs Bamboo, we use OSGI at runtime to kind of pick all those pieces up and then compose them into a single web application. That's the ideal anyway. We're not fully at that point where everything is a plugin. There's still a lot of big monolithic code still lying around, and the objective is to get rid of as much of that as possible. Yeah? Yeah, that's true. There are certainly some developers at Atlassian who love being on bug fix, which is really great because part of that transfer in and out of... So the answer is that we rotate people out of that team. It's a permanent team, but the staff that are on it changes over time. And it's doing that rotation is a great way to get new people up to speed because they're going to touch all these different parts of the code base very quickly. And also it's a great way for everyone to kind of feel a little bit of the pain that is a natural part of software development, right? So part of what I said about feature warranties is getting people to accept the consequences. Spending time on bug fix gives you a good understanding of what kind of a death by 1,000 cuts can feel like. And it makes people feel more passionate about solving that problem. Anything else? No? Okay, thank you.